those issues can be divided into three issues, but this moment I'd like to focus on the science and technology. If the data and the overcome the shortage of data and few reliable methodology, then we will be able to advance the science and technology point of view. Then we will be able to get the advanced achievement and knowledge. There are many role of science in adaptive development, such as there are many subjects, but those are very limited. So maybe the other panelists will add or improve or change of the issues I am just writing now. So let me focus on the third subject in red, which proves the necessity of adaptation against each issue. At this moment is about the storm surge and the inundation problem. Let me show one of the examples for proving the necessity and the effectiveness of adaptation against the storm surge and inundation issue. You look at this here, which show the predicted results of the inundation area in Asia Pacific, Asian Oceania without protection in 2100 using a scenario A1B in a stress scenario of IPCC. You can see that there are many areas which will suffer from the inundation in 2100. However, look at this figure. If we put the protection, then that area will be decreased dramatically. Those results those results has been obtained by the Maruyama, Mimura. Professor Mimura is a colleague of my university. This is I think this is a very interesting figure that this showed influence of population against the elapsed years in a global and the Asian scales using scenario or A1B. There are 2 points I would like to emphasize. One is the dramatical decrease of influenced population using protection, with protection, which is independent of the Asian scale and the global scale. Another point is that if you look at the figure, so the influenced population decreased from around the 2030 or 2040, and that is because of the economical growth. Let me show approach in Japan to this issue. That we have been working, we have done work on one project, and then we have just started another project supported by Ministry of Environment. The previous project was published in both in 2 publications written in Japanese and written in English. If you want to see or get both, then I can distribute to both. And also, as far as the adaptation, the effect of the adaptation is shown in the what is called risk map. In the risk map, you can see that the effect of adaptation measures is very eminent when you comparison the figures, upper figures and the lower figures. This is one of the achievements. We have got many achievements from this project, but one of them is I pointed out. We would like to move to, now we have just started to the strategic project, so-called 8.4. We have 3 themes, reliable evaluation of a global warming impact, second, community-based impact evaluation and adaptation policy. And this third group, that is, I am responsible for leading the theme 3, which is the index for evaluating vulnerability and adaptation in the Asia-Pacific region. Now, let me summarize. I think I have already spent 10 minutes, so let me make a summation. As I mentioned a moment ago, there are many roles of science for adaptive development. So I put the several issues, the roles of science and technology. However, the panelists, distinguished panelists would like to make additional comment on the argument or criticize, which are very welcome. And however, and also the audience will make some comment on the opinion, which is also welcome. Last subject is to develop a methodology for producing the reciprocal and the multiplier effects from the mitigation and adaptation. This is in response to a comment given by Professor Lakshit. He kindly gave a comment to me a few days ago. Thank you very much. Thank you very much.
Ladies and gentlemen, we have a distinguished panel with us today. I would invite each one of them to present the views for about 5 to 10 minutes. First, I would like to invite Professor Nathan, Research Professor, Stony Brook University, US. I think Professor Thun is very well known for all of us, but a few lines about his impressive background. Professor Thun is Research Professor, Department of Technology and Society, State University of New York at Stony Brook. He is also a visiting professor at the Imperial College London, visiting professor, senior advisor, Asia Pacific at Lund University, Sweden, honorary professor at Tongji University in China, visiting professor and advisor at Chulabon Research Institute in Thailand. He was UN Assistant Secretary General at both UNEP and UNDP, and was also seconded to UNCD Secretariat, where he served as Program Director and Special Advisor, and helped organize the 1992 Rio Earth Summit. Before joining UN, Professor Thun was Department Manager at Exxon Thailand. He's also a board member of a number of not-for-profit research organizations. I'm especially proud that he's a very close friend of AIT, our former faculty, and a mentor and advisor in many issues, in many platforms where AIT is also involved. Very welcome, Professor Thun. The floor is yours, please.
Thank you very much, President President Said, I think in this room of this size, I think you should be able to hear me, because usually I need both hands. Headline, front page, floods threaten 6 provinces. 6 articles, separate articles in this paper that talk about floods, climate change, hydrometeorological conditions. One of the articles in here says the impacts on women and children. Today, headline news too, 6 provinces. Second article in here talks about diseases. So when we talk about climate change, it's not only flood, but as Professor Yasuhara has said, and our moderator has said, there are important social, economic, health, cultural consequences. With that as a start, this is forward. Allow me to share this chart with you about the great transformations that are taking place. I want to highlight a few here. It's systems and systemic transformations. We need to move away from looking at particular sector and particular discipline, just atmosphere or hydrosphere, or just agriculture development or water development. We need to look at it from a system point of view and systemically. We look at it, myself and my colleagues, there are 4 major great systems with 4 transformations taking place. Start off from the top, dear to all of us, it's an ecosystem change. Not only air, but the water, the forest, the hydrosphere, the biosphere, etc., terrestrial lithosphere, all changing. When that changes, the way I had my arrow before was the reverse. Ecosystem changes affects the social systems. The social system affects the financial and economic system, and then affects the political system. At the heart of this is climate. And what's driving it is energy. But there is another commonality. It's the carbon that is in it. And that's why increasingly at the international arena, we are talking towards of going towards a low and lower carbon economy or a low carbon society. So that's at the very, very heart of it. When I run through this, through a number of colleagues, and particularly a person who is, I respect immediately, at the highest political level, research, university president, etc., in the United States, and he was the right-hand person of a recent president, he said, Nathan, this is good. He said, but your arrows are wrong. Right at the heart of it, that big arrow there, it affects the political and governance system. We must never forget that. Reverse your arrows around. When that happens, it sends a signal, or does not send a signal, to the financial economic systems. And then that moves the social system, and then the ecosystem. You guys in the environment, you talk about the ecosystem first. Important, but it's not resonating. So, my PowerPoint